In your 9 a.m. physics class, you dream you're in a stagecoach in the mythical Wild West, when suddenly you're ambushed by bandits. At gunpoint, they demand that you hand over all of your spheres of constant charge density, along with their fields and potentials everywhere in space. Think fast. How will you comply and provide your highway robbers with these things they value? Hi all, Dave here. Apologies for pulling you away from a swashbuckle physics dream. But I have a question. Why did all those bandits value spheres of constant charge in their fields and potentials? In this video, my objective is to convey the value you add to problem set solutions and to connect your experience with P-set problem images to reading and producing complex texts in your ultimate fields of expertise. I'll survey features of images from electricity and magnetism curriculum in preparation for taking a look at a sample research article. I will have succeeded in the short term if you start thinking productively about the visual displays of information in your end-of-term project, and in the long term if your journey to expert reader and producer of graphics becomes more efficient. A P-set problem and its solution might look something like this. An image that'll transform into a vector graphic format because before long, I'd like to put the P-set solution on the same footing as a journal article. The major features that I've shaded are 5 different representations: text in blue, equations green, graphs Milano red, a field line yellow, and an iconic drawing of a bowling ball of charge, tango. Yeah, okay, I know. A tango is supposed to be a dance, not a color. But if it were a color, it would be halfway between mango and tangerine. Together, these elements argue for the correctness of the answer. It's nice to get the correct answer, but more important to argue the answer's correctness, because soon you'll be solving problems whose answers are unknown. Here in the P-set solution, the argument moves from the context, reality, the bowling ball of charge, to the problem, to the solution method, which is a modeling exercise that applies the state of the field to the problem at hand, to the conclusion or answer. The Reader's Digest version sounds like:
Theory says, apply Gauss's law, 802 trickery, invoking symmetry, yay math, apply the definition of potential, invoke symmetry, do more math.
The result is a pair of equations, their graphs, and a field strength representation of what theory says one will find when investigating a ball of charge. As an aside, amps in his peep about the experimental design, measurement, or data. Nonetheless, for the expert reader, this means you if you're 8 weeks or more into the 802 curriculum, the argument for the validity of the answer is complete, based on a trove of unstated understandings that are part and parcel of the 802 knowledge domain. So why are all these representations important? Putting the question another way, why are these features so prevalent as pieces of arguments in engineering and science? And why bother taking up real estate on the page with an equation, graphs, and arrow representation for the magnitude of the electric field? Don't all these representations convey the same argument? One answer to these questions comes from community of practice theory, which suggests that communities of practice exist to help members learn and solve problems. Rhetoric theory suggests that genres, for example physics problem set solutions and engineering journal articles, solve common problems for a community of practice. And a specific article from the Journal of Mathematical Behavior suggests how expert practitioners use multiple representations as they read to learn. I provide the entirety of Table 2 because the range of reading characteristics as they proceed from novice to expert might be of more than casual interest to you. But the element that strikes me is how experts use multiple representations. Expert readers use the multiple representations as checksums to make sure that content is being understood correctly. If the equation and the graph are in agreement, then the reader could move on with a high certainty that their understanding is correct. And, for bonus understanding, experts generate their own additional representations, as if reading text closely implies creating more text in different representations. To be sure, domain expertise goes a long way towards making the reading of technical text easier on some obvious counts. For example, discipline-specific jargon and symbols are effortlessly understood. But the tremendous advantage of expertise is being able to connect the elements conceptually. Here in the 802 P-set solution, there are 2 sets of concepts, one from discipline knowledge, the connection of the concepts of charge, field, and potential, and one from the rhetorical world that connects a theory or a model to the observable world. Well, Now you know 4 kinds of figure-based structures for sorting out dense technical text. A genre structure that moves from context to problem to solution to results and conclusion. Discipline-specific structures that mirror the underlying basis of the field. A rhetoric-based structure that organizes information according to its representation. And a structure at the intersection of STEM disciplines and rhetoric that organizes text in terms of the connections between form and function, or phenomenon and theory, according to design, build, model, and experiment. If you're finding reading challenging, play some variations of connect the dot games. In one, connect the figures by binning them according to different structures. Alternatively, play the game backwards and see if you can sleuth out unknown discipline-specific concept bins from the figures. That's it for content in this video. Next up are some exercises for the viewer. I'll provide a sample journal article to challenge your technical reading skills. Can you use the content of this video to help you read and understand this text about how bats drink nectar? If things go well, there'll be a follow-up video that uses this text as the basis for observations about data abstraction. And for the second exercise, I'll let you back into your Wild West dream. You've successfully thwarted the bandits, but now your stagecoach is driverless and the horses have taken off with the stagecoach in tow. How will you keep the passengers from certain demise? A problem that might be addressed by kinematics, power analysis, and leaping from horse to horse.